Hello! Welcome to the tutorial on the World Wellbeing Project's Age and Gender Predictive Lexica. In the next few minutes, you will learn what constitutes a lexicon and what makes it a predictive lexicon. We will then demonstrate how well our lexica do at predicting someone's age and gender in different situations, followed by an explanation on how we made these lexica using real social media data. Lastly, we will walk you through a concrete example on how to use these lexica using our online tool at lexhub.org. Before we delve too far into specifics, let's review what we mean by lexicon. A lexicon is traditionally a list of unweighted word category pairs. Categories can be any grouping of words, and words can belong to multiple categories at once. On the right, you can see a mock lexicon. In this lexicon, yay and bacon are considered happy words, whereas sadness, Monday, and the two emoticons are considered sad words. The other type of lexicon is a weighted lexicon. The weighted lexicon quantifies how much each word belongs to a certain category by giving each word category pair a weighting. As you can see on the right, the weights are useful to quantify that bacon isn't as happy of a word as yay, and that Monday isn't as sad of a word as sadness. The motivation behind our age and gender predictive lexica is the following. Traditionally, in psychology and other social sciences, lexica, also called dictionaries, are hand-curated, man-made lists of words that are put into categories by experts in these respective fields. Because these lists are created by experts in their field, lexica are highly trusted and widely used by social scientists. However, since people often forget that words have multiple meanings, these top-down lexica are not always very accurate. For instance, the word please can be considered a happy, positive word when thinking of it as pleasing someone. But most of the time, when someone says please, they are just being polite without being particularly happy. The main reason for starting this work was to take tools and methods from computer science and bring them to the social sciences. This would then result in an easy-to-use tool that is as accurate as other natural language processing or NLP tools. The objective of these lexica is to determine an author's age and gender given only a sample of their written work, social media or otherwise. This is why our lexica are predictive. By counting up words and weights, we can predict the author's age and gender. You might be wondering why this matters. Language, health, and behavior have all been found to correlate with both age and gender. For instance, women tend to live longer, and people tend to become more conscientious with age. Using individuals' Facebook posts, the World Wellbeing Project has identified words that distinguish men from women. Note that some of these words shown are of an explicit nature. At the top left corner of the screen, you will see an example of words that are characteristic of 13 to 18-year-olds. At the bottom right corner, an example of words for people over the age of 30. In order to build these predictive lexica, it requires a lot of real-world data. To ensure that the models can apply to multiple types of language samples, such as blog posts and tweets, we use 3 domains of data. First, we use the entire posting history from roughly 73,000 consenting Facebook users. Next, we use the entire posting history from roughly 14,000 blogger users. And finally, we use tweeting histories from about 10,000 public Twitter users. While age and gender information was reported by Facebook and blogger users, Twitter users typically don't provide this information. Gender information was found for these individuals by following links in their Twitter profiles to a blog or LinkedIn profile that did divulge gender information. In order to determine the most accurate age and gender lexica, we first created lexica on each individual domain. For gender, we built one lexicon only using Facebook posts, one only using blog posts, and one only using tweets. The final gender lexicon was created by concatenating the 3 domains together. We evaluated the performance of these 4 lexica on 3 test sets of people whose posts weren't used to create the models. The numbers we're presenting here are accuracies, meaning the percentage of users in the test sets whose gender we correctly predicted using the lexica. Note that the baseline assumes everyone is female. As you can see, models trained on Facebook alone perform best when applied to Facebook data. The same thing happens on Twitter. Interestingly, a lexicon built on blogger data doesn't perform as well on any of the 3 test sets. This suggests there's something about the nature of blogs that make them harder to extract gender from. The gender prediction is overall the best when building the lexicon using data from all 3 domains, Facebook, Twitter, and blogs. In fact, the 91.9% accuracy on Facebook is in line with the state-of-the-art gender prediction to this day. Since this last lexicon was the most accurate, that is the one we are releasing. Here's how we performed when predicting a continuous age value for the users in our Facebook and Blogger test sets. Remember that the Twitter data didn't contain any age information, so we cannot use it here. The numbers you see here are Pearson correlation coefficients, and the baseline we used was predicting everyone as being the same age. As was the case with gender, lexica perform best when tested on the domain they were built on. When we combine the domains, we get a better overall performance, which is why the combined lexicon is once again the one we are releasing. The 2 previous slides brought up a point about the domain adaptability of these lexica. We noticed that lexica built on individual domains usually perform better on their own domain. Moreover, Facebook and Twitter are more intrinsically similar in the sense that people use them in more similar ways than they do blogs. Most blogs are often longer and in more detail, and they are usually more thought through than a tweet or a Facebook status update. This suggests that when using the lexicon yourselves, the age and gender predictions will be more accurate for text that is written in the style of Facebook and Twitter, and will get less and less accurate for text that comes from a newspaper article or a radio interview. One question you might be asking yourselves about these lexica is, how many posts or words do I need to get an accurate estimate of age and gender? We took various numbers of Facebook posts per user, here the x-axis, and observed the performance of our lexica. The first thing we notice is that no more than 100 posts are needed to get an accurate prediction of age and gender, since the curves taper off after that. Another thing you can see is that if you only have 20 posts per person, you can get a gender prediction with roughly 80% accuracy and an age prediction that is correlated at about 0.7 with the actual age. This is good news if you don't have the infrastructure to handle many posts per person. Now that we have seen how well we can predict age and gender, let's see how these lexica were actually created. This next part is going to be a bit more technical and math-heavy. Don't worry if you don't completely understand everything. You can even skip ahead if you want. Typically, when you extract a lexicon for a user, you take the relative frequency of each word and multiply it by the word's weight in the category you are considering. The relative frequency for a given word is the number of times the word was used divided by the total number of times any word was used by the user. It turns out this equation is very similar to the one defining linear multivariate regression, a standard technique used in computer science and statistics to build predictive models. In the linear regression equation, where features are words, you're performing a weighted sum of the feature values, x sub f, in this case the relative frequencies of each word. The point of the regression is to learn the weights, w sub f, for every feature. You are essentially learning a weight for every word. You might notice that there is an extra term in the regression equation, w sub 0. This term is called the intercept and isn't included in the standard lexicon extraction equation, yet for the age and gender lexica, it needs to be added after the lexicon extraction has been done. This will all be more clear when we walk through a concrete example right now. In this example, we are going to manually extract a mock-weighted age lexicon for 2 users. Feel free to pause the video at any time if you would like to read everything more carefully. As you can see, the age lexicon has 3 words in it, and each have their weight. The lexicon also has an intercept value, which we'll have to add to the lexicon usage at the end. Let's consider 2 users who have written some text, and each user's word counts are listed here. User 1 used the word home twice, the word sun 10 times, etc., whereas user 2 used the word home 5 times, and the word sun only 3 times, and so on. Once we have these word counts, we are going to plug everything in the lexicon extraction equation that is here. In order to do that, first we need to know what the total number of words written for each user was, so we are just going to sum up all the counts. So we have that user 1 wrote 25 words in total, and user 2 wrote 30. We can now plug the values into the lexicon extraction summation formula as such. So user 1 has a lexicon usage value of 34.24, whereas user 2 has one of 5.2. However, as I said before, we still have to add the intercept to get the accurate prediction of age. We end up with user 1 being predicted to be 56.5 years old, and user 2, 28.5. And that's how you extract a weighted lexicon with an intercept. As some of you might have noticed, all of the lexicon usage scores in the examples were real valued because they were ages. Lexicon usage values will also be continuous for gender, so we have to manually classify the users into either the man or woman category. Note that those were the only 2 categories the Lexica was built on. Luckily, it's really easy. If the gender score we get is positive, the gender is female, and if it's negative, the gender is male. Now that we've gone through an example of a mock age lexicon, let's try it on a real dataset in the real age and gender lexica. Let's grab 25 of Taylor Swift's latest tweets and try to predict her age and gender. I went to her Twitter page and copied the text from her tweets and put them in a text file. We're going to use the online weighted lexicon tool on lexhub.org/tools to extract the age and gender predicted from these tweets. First, let's go to lexhub.org on a web browser. Once there, let's click on the Tools section. The tools we're going to use is the Lexicon tool, which is the first tool listed here. Now we're going to add the text we want to analyze. We can do so by clicking Add Your Text, which opens this pop-up. We're only uploading one text, so let's choose the Single Text/Document option. We're going to copy-paste her 25 tweets into this text field, which we have right here in a text file. Now that it's pasted, we can click on the Step 2 button, where we can name our text. Let's name it Taylor. We can move on to Step 3 and click Done. Our text has now been uploaded temporarily. Now we can choose the lexica we want to extract for this text, which in this case is the age-gender lexicon. This tool allows you to select specific categories within each lexicon. But here we're interested in age and gender, so we're choosing Use All. Once we agree to the terms of use, we can click on Run Analysis. This brings us to the results page. We can see that our lexicon predicted Taylor's age to be 23 years old, which is only 2 years away from her actual age. The number next to gender is positive, so that means the lexicon has correctly detected that Taylor Swift is a woman. So there it is, an easy-to-use tool to find the age and gender expressed in a set of text. Don't forget to cite us if you use our tools. Thank you for watching this tutorial on the World Wellbeing Project's Age and Gender Lexicon. If you would like to know more about the lexicon and its creation, you can find the original paper on the World Wellbeing Project website, linked below, or lexhub.org/articles. Please check out our website, lexhub.org, for other tutorials, as well as lists of useful tools, datasets, and articles that lie at the intersection of social sciences and computer science.